Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure how I'm going to tell this. I'll tell it how I tell it when I title the video. But what I am sure of is our one goal for today. And that's to recognize hidden congruences to determine if triangles are congruent. This is going to be a very short lesson. It's a supplement to 20.2, 20.3, 20.4, and 21.2. So this will help us determine if triangles are congruent. So let's just go ahead and jump into our first goal. Sometimes in pictures, congruences are not marked, and it is up to the student, which is you, to recognize the hidden congruences. I have 5 listed. There might be more. I think this covers them all though, but hopefully you'll get the idea. Our first hidden congruence is vertical angles. So if you have a shape like this, or you have triangles that look like this, you know, let me grab a red marker, you know that you have a pair of congruent angles because vertical angles are congruent, right? Vertical angles are congruent, or equal. So again, they're not going to tell you, but you have to figure it out. It's a hidden congruence. The second hidden congruence is the reflexive property. And if you have triangles that are next to each other like this, you can say that the side that they share, the shared side, is congruent. You get a congruent side. That side's the same side as in both triangles, so you get a free congruent side. Our third hidden congruence is because of alternate interior angles of parallel lines. So students struggle with this one, and I'll show you why. If you have triangles next to each other like this, not only do you have the hidden reflexive one, but you're also going to get a pair of congruent alternate interior angles. Now, I'm not marking these angles, and I'll show you why. I'll show you why. Okay? So this picture is, I'm going to show you with this picture how the parallel lines cut by a transversal becomes this. Okay. How we get this. All right. So we know that alternate interior angles are congruent. We know that. I got 2 pairs of alternate interior angles. Now, let me show you what happens. In order to turn this into this, I need to connect this intersection to the other line and this intersection to the other line. Notice I cut into this angle, so I can no longer assume that they are congruent because it's a part that's cut into it. And I can't assume that these sides are parallel. So I'm only left with one set of congruent angles due to alternate interior angles of parallel lines. I'm trying to walk and chew gum here, and I'm struggling miserably. All right, so hopefully this explains how that prior picture turned into this. They're a little bit different size, but that's okay. All right, the fourth hidden congruence is you're going to see the word bisected. Okay, that tells you that you have equal segments or equal angles. And the second, fifth hidden congruence is midpoint. So if you have midpoints, then you have equal segments. If you have bisected, you have equal angles and equal segments. So hopefully this helps clarify the hidden congruences. I apologize. My AC unit won't turn off. It's been running for a long time. I kept waiting and waiting and waiting for it to stop, and it wouldn't stop. So hopefully you can hear me over this. It sounds like I'm on a plane. Anyways, I'm going to go ahead and end it here. I hope everybody is doing all right out there. Have a great day, everybody. Bye-bye.